Okay, so I'm going through Pensrow again. I want to give some special notes out to him. Well, I like Pensrow. Firstly, let me begin by specifying that. As far as Bell's inequality or Bell's equality here, what I'm doing is very practical. It's good that we come on divergent paths but have different sets. Now, I don't know what kind of personality type Pensrow is, but you have to keep an ear on things for the tone, heat, light, and sound. So you have to be careful of those twisters when they pop up, how to recognize them, how to understand the inversion on that, tap to the drain. This is going to be a lot of Bernoulli does this boat float. So technique-wise, it's important to kind of understand where Pensrow is coming from before we get to the topological questions later. So you're going to have to listen to me. This is pretty freaking good. He's even playing little stuff with the projector, so I got to get the head working relative to just very slight undertones to the conversation that if you weren't careful with the witticisms, you wouldn't really understand. But there's some questions here. I wanted to get specifically to the questions.
Between the Z's and the W's, but the Z's commute with themselves. Now, if you do the Dirac
you have to understand, the twister theory is a very psychologically heavy base mathematics. Now, again, because he has the pipe works for Bernoulli,
and then that's the expression I've got written out at the bottom here.
But he'll talk about this subject matter anyways later. So the metrics, people don't understand this theory base. People wouldn't want to use my bluestone militia technique. I sit them down. One, you don't have field theory. This is about as clean as you make it. Short of 3 blue, 1 brown. And in terms of what type of mathematics, at the simplest forms where you can tell he'd been putting 40 years on his twister theory before he added the cosmological constant, or 1 to the set. I need black holes, I need suns. So they're not just supernovas. They're compelling arguments that become twisters in this theory, M1, M2, Mn, zeta into the cosmological constants, which I'm going to use into the thesis where I'm breaking down 36 subject pieces if I can get them all in there. And then, again, to the atom.
I had a quick slide earlier on showing you how you might expect to put massive fields in here. But this is all vacuum.
Laplacian. Dimensional analysis being one of the numbers that's missed here too. I forget which type of analysis they're using. Complicated analysis for complicated integers or whatever. We'll have all that terminology coming in here. This is a course that'll help you do it. You don't need the whole thing for an hour. It's part of the non-Newtonian, non-local matters. It's in here percentageably though for Schrodinger's numbers of students, turn, YF over X, trips the rabbit trap, kind of stuff that goes into this. So I'm giving him special positions in the key for spin measurement direction where it has a cross on the bars in shape to starting left and right, X, Y, 0, 1, and then any other relative direction.
Yeah, but you see this again.
He's talking about matrix. Go into a different class. Go into a different study. This is a vacuum. Math is a vacuum. Even if you get 1 or 2 theories in here, there's going to be an entropy problem of you condensing the material like what I'm going to do with this material already. In line, because there's going to be 3 pages before I get to particles, Feynman, some heavy-duty chemistry numbers on 3-ion position and stuff like that. I want the key matrix in there because it's heavy like that. Periodic table, AUAX is a triangulation to SOHCAHTOA. And here's a bunch of methodologies. Not only is it a bunch of methodologies, they have their own polarized, phased, cellular aspect that you put into this. So what would be relative to you is this wave function, right? For this person on the target range, bang, 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 bang. For you, on the other hand, how the situation is coming at you isn't this gravity. This twister metrics at the singularity, half of it positive neutron, and then so you are this twister. So you are a particle, you are a ball.
The metric comes in
and Pensrow as well, but obviously he's got
But then the
quite a bit more
quantization
momenta
procedure, if you
on
like,
there, and he actually brings up that
it gives you
topological matter
this
in
thing
here. It says
here,
you
and
need to
what
be
it needs before
infinitely
you do
traveling
that,
at the
you
speed
get
of
the
light.
Einstein equations.
So I
The
need
Einstein
something that
equations come along
values
with the
C
metrics,
mathematically, like
which
in
is
the
sort of
stone
curious,
mill,
but that's what
to
happens with
equate
theory.
It's fantastic.
where gravity changes over, but it's an equal equality to an inequality of the time that we have to have. So I thought that was cool, and like I said, I'm going to hammer through this and get this done tonight. Hopefully I can just get all those on there, and just keep listening to it, go through it, pick up some key terms, make sure I write those key terms down, because they're going to be your Riemann tensors and your anti equality issues with two states of G, H, I, K's, P's, Q's, and P's, and still a lot of ground in there, so you got to keep an eye on it. Catch you on the next one.